Okay guys, so what we're looking at today is kind of the very beginning of the new chapter, and what we have today is a lot of vocabulary. Some of the vocabulary that you're seeing right here on the screen is probably things that you are familiar with. So for example, parallel lines, I'm going to guess that many of you, if I said what is parallel, that you would know that those are lines that do not intersect. And so I'm going to go ahead and fill in that part. The key about parallel lines, though, is that not only do they not intersect, but they also have to be on the same plane. So this fill-in is going to be coplanar. So they are coplanar lines that do not intersect. When we're talking about symbols within the picture, if you look at the picture, you have these little arrows marked. That means that those lines are intended to be parallel. So arrows are used to indicate that the lines are parallel within the picture. And then when you're looking at symbols, the symbolic notation, okay, we know that to name a line, we have to use two letters. So line AB, okay, with the arrows on the top, and line CD. And the way that you see that those are parallel is that you have this symbol in between them. It looks like slanted parallel lines. And that's it. So again, within the picture you have the arrows, and then the symbolic notation you have that symbol for parallel in the middle. Now, parallel planes, that's something, again, that you're probably familiar with. If you think about within a room, you have a ceiling and a floor. Those lines are considered, those planes are considered parallel. Those are just planes that do not intersect. So if we look at our picture to the left, we have plane J. Remember, we can use that capital cursive letter. And then we also have plane K, and that those are parallel. So again, you have that symbol for parallel in there. Now, the one that you guys are probably not as familiar with is skew. So skew lines, those are also lines that do not intersect. However, instead of them being coplanar lines, like parallel lines are, these are non-coplanar. Okay, so what I want you to think about right now is if you were sitting inside this box, and I'm just going to put a little X here. So if you were sitting inside this box like you are inside of a classroom, then non-coplanar lines would be an example. You would have the front and the ceiling where those two planes meet. And then behind you, you would have this vertical line behind you where the two walls meet. If you were to extend that front crease and that back corner forever, they will never intersect. However, they are not on the same plane. So what I just highlighted in purple, that would be an example of skew lines. So you have line WD, and you also have segment TT. Now, besides just the one over your back left shoulder, you would also have the one over your back right shoulder. So we could do WV and Q. Now, let's go ahead and get rid of the WV entirely, and let's look at an example like QR, and then maybe even, TU. Those would be another example of skew. We have a lot of skew pairs in this picture. Okay, but the key is they have to be on a different plane, and they can never ever intersect. So let's look at some examples. If you look here, it says name all segments parallel to AE. If we look at AE, it's running vertical. So any other segment running vertical would be considered parallel. So you've got segment BH, you've got segment BF, and you have segment GC. Anything running vertical is going to be considered parallel to EA or AE. When you're talking about the examples of parallel planes, you actually have three different pairs of parallel planes. If you think about sitting in a room, you have the ceiling, you have the floor. Reminder with planes, you only need three letters to name it. Okay, so if I'm looking at the top of this box, I can pick any of those three letters. So I can do E, F, G. Technically, I could use H instead of any of those three that I picked. We're talking about the floor, because the ceiling and the floor are the parallel ones. So looking at the bottom, we can do A, B, C. And again, we could use D in place of any of those three letters. If we're looking at another pair, you could do the left and the right. So if you look at the left side, you've got plane ADE. Again, I could use H in place of any of those. And then at the right side, that's going to be parallel, would be plane BCG. And again, I could use F in place of any of those. Now I could also do the front rectangle and the back rectangle. That would work as well. Okay, so now the one that is skew. Let's talk about the skew one. So name all segments skew to GH. So what I do to help me see it, I'm a visual person, is I go ahead and outline the ones that won't work. So first off, we know to be skew, they have to be non-coplanar. So I'm going to eliminate all of the lines or all of the segments that are in the same plane. Okay, so HG is part of the top. So is this, so is this, so is this. HG is also part of that back rectangle. So is this segment, and this segment. Okay? We also know that they cannot be parallel. So if HG runs horizontal or left to right, the only other segment that does that isn't already outlined is AB. Okay? Yes, we have EF, we have already outlined it. Yes, we have BC, but we've already outlined it. Now, the reason that I outline those is because now, at this point, anything that isn't outlined is considered skew. So along the left-hand side, I have segment BA. I also have segment BE. I also have segment BF. And I have segment BC. So all of those segments would be considered skew. Okay, looking at number 2, name all segments parallel to JK. If you look at JK, it's running this direction. None of the other segments along that pentagon work, but back here along the back side, we do have segment OP. If we're looking at all of the segments parallel to NS, we've got all of the segments running in that same direction. So I'm going to go ahead and outline those real quick, and we're going to go ahead and write those. So we've got MR, we've got segment LQ. Okay, reminder, don't forget your labels. You've got segment KP, you've got segment JO. All of those are parallel. And again, don't forget the labels for segment on top, that little dash. Name a plane parallel to plane JKLM. Now, notice that this does have 4 letters. Okay, some books and some different worksheets will use more than 3 letters to name a plane. The key is that you have to use at least 3 letters. For consistency's sake, we're going to use 3 letters just because that's the way that I taught you. That's the way most books teach, but again, some different documents will have more than that. So JKLM, the plane that is parallel to that is the other pentagon behind. So you've got O, P, Q, and again, you can use R and S in place of any of those letters, and you'll be fine. Okay, the last one, name 4 segments skew to RQ. So we have RQ, and again, I'm going to eliminate the lines that are on the same plane as RQ. So we have this rectangle that's on the same plane. You also have the pentagon on the back side here that's in the same plane, and we would eliminate anything else that's parallel to that. The only thing is, the only line that is parallel is this ML that we've already outlined. Everything else that we have yet to name is considered skew. So we've got segment NS, we've got segment JO, we've got segment NJ, we've got segment JK, and any of the others that we did not outline, those are considered skew. So I'm going to actually put that here because there's a couple more. Okay? So that is parallel and skew, just kind of a quick summary. When you flip this to the back, you're going to see a couple of other different definitions here on the back, and these are talking about some angle pairs. First thing that you want to see is this word transversal. A transversal is just a line that intersects 2 or more lines. So if we look at our picture, this is the line that intersects 2 or more lines. We've got 1, 2 different intersections. So our example from our picture is line C. Corresponding angles. When we look at corresponding angles, the key is that they lie in the same position. Okay, so they're angles on the same side of the transversal and in the same position. The way that I always encourage people to identify corresponding angles is if you draw a box around each intersection, they're the angles that lie in the same spot. So for example, angle 2 is in the upper right, angle 6 is in the upper right. So angle 2 and angle 6 are considered corresponding angles. If we look at, say, the lower right and the lower right, angle 3 and angle 7 would be considered corresponding angles. And then you can do 8 and 4, 8 and 4. Those would be considered corresponding angles. And then the last pair in the upper left-hand corner are angles 1 and 5. So they are in the same position if you were to draw a box around each one of those intersections. Okay, and then we have these words interior. So we have interior versus exterior. So let's talk about the interior ones first. Interior means inside. So what we're talking about is inside these non-transversals. So if I look here and kind of draw a box around that, inside is going to eliminate these angles right now, because inside the box is going to be right there. Alternate interior are going to be on opposite sides of the transversal, but not adjacent. Not adjacent means not next to each other. So 4 and 3 can't work because those are next to each other. So what we're going to do is we're going to go kind of diagonally. So angle 4 and angle 6 could be considered alternate interior, and then you've got 3 and 5 would be your other pair of alternate interior. Okay, when we look at consecutive interior there at the bottom, consecutive is interior angles that are on the same side of the transversal. So if we're looking, these are both on the left-hand side. So this would be angle 4 and angle 5. And then angle 3 and 6 are on the right-hand side. Those would be considered consecutive interior. Some books and some documents refer to these as same-side interior. So if you see same-side interior, that is synonymous with consecutive interior. And then the other group that we're looking at here is the alternate exterior angles. So again, exterior with respect to those two lines. Oops, excuse me. Okay, so I'm going to draw that box around there again, but I'm going to cross off the inside. Alternate exterior. Okay, again, they're on opposite sides of the transversal, so we're looking diagonally. So angle 1 and 7 are alternate exterior, and then you have the other pair, 2 and 8, would be your other pair of alternate exterior. Okay, so look for those keywords: interior versus exterior, and then alternate versus consecutive, or in some cases, same side. So what I'm going to do is walk you through an example of how to go about figuring out the types of angles that we're looking at. Now, keep in mind the directions do say there's no relationship, right, none. So that is a possibility. So what we're looking at, angle 1 and 8. If we look here, the question that I want to ask you to constantly consider to start is, are they inside or outside those two lines? So are they interior or exterior? Or in some cases, you may have one of both. So if we look, they're on the outside, and then they are on opposite sides of that transversal. So they are alternate exterior angles. If we look at 2 and 3, 2 and 3, again, if you think about that box, they are inside. And so we think about inside, we have either alternate or same side, consecutive. They are on the same side of the transversal, so they are consecutive interior angles. If we look at 5 and 7, and we think about that box around there, you notice 5 is on the outside of that box, 7 is on the inside. So instead, now if we think about those intersections, we have to ask ourselves, are those in the same location? They're both in the bottom left-hand corner, so they are considered corresponding angles. Now, if you have a pair of angles that don't fit into any of those categories, your answer is none. So let's say that we would have had 5 and 3. 5 and 3 would have been a none because you have one of each, and they're not in the same location. Okay. Moving on to 2 and 7, you have them both on the inside, so they're interior. They're on the opposite side of the transversal, so they are alternate interior angles. And again, if the opposite side of the transversal doesn't make sense to you, think about it. You have to cross that transversal to get from one to the other, or you have to go diagonally. 1 and 3, again, if we think about that box, one is on the inside of the box, one is on the outside of the box. So then we go to, are they in the same location? And indeed, they're in the upper left-hand corner. So they are corresponding angles. And then last but not least, 6 and 7. Again, they're on the inside of the box, so they're interior. They're on the same side of the transversal. They are considered consecutive interior angles. Okay? So what I'm going to have you guys do is look at the next example, fill out what you think to be true about those angles, and then from there, I'm going to have you guys go ahead and check your work. Okay, so if you would take just a minute, go through your angles, check your work, make sure that you recognize that both H and I are considered none. Okay, notice there it does say that the angles must belong to the same transversal to be an angled pair. So that's why if you look at 6 and 11, if you think about this, there's no transversal that connects them that way, and there's no transversal that connects them this way. So that's why 6 and 11 are no. Okay? As always, guys, feel free to ask any questions that you may have, and we'll do our best to work through it. Thanks.